Good afternoon. Thank you for those who came out. Yeah, great to see you here. I hope you guys have had a great conference so far. So the topic that I want to share with you, to me, it's a space that I find really interesting, and it's around the space of real-time analytics. I've had the opportunity to work in the analytics industry about 20 years now, and there's been this really large body of knowledge that we've got around how to build deep insights, right? And how to build architectures for big questions and really being able to dig into these large data sets. But increasingly, more and more of our customers are moving into these real-time architectures. And what I find is really the common thread is when we get down to the discussion of why are you architecting and how are you building the right solutions, it's around what's the window of opportunity you're trying to capture. So what I want to share with you guys is some of the patterns that we've seen and how they're choosing services underneath to be able to build to meet those windows of opportunity. Because it's so easy to either over-provision or under-provision when you start operating at big scales. So we'll cover two things. The first is we'll look at a couple of the customers that we've got who are building real-time analytics at scale. And the second is when you're getting started. So when you're running your first real-time workloads, how can you start to build in a way that it's not so expensive up front that it prohibits you from being able to scale up. So I'm going to show you how to build a real-time analytics platform for under $1,000 a month, how to get started with that. So the first thing I'd like you to do is I want you to imagine when you think of a real-time opportunity. So you're looking at something, some sort of situation that you've got where you're trying to capture analytics in real time. You're trying to respond to an event. Take a minute and think about what's the first situation that you think of, the first real-time analytics opportunity. Like for me, when I was putting this together and we were looking at some of the cases, the first thing I think of is fraud analytics. You swipe a credit card, and if you're traveling, you've got like a certain very small amount of time before you're flagged where it's fraudulent or not fraudulent. So I started really putting this together and saying, well, what are the other sort of cases and what are the windows? So the first thing that we look at is that real-time doesn't look the same for everybody. For each one of you, when you're building your architectures, the shape of the data and the type of business case is going to look really different. So I live in Singapore, and I went down to the train station, which is the MRT, and I took this picture, and I looked into say, okay, of all the things that are happening here, what are all the different real-time cases that we can see? And then how do they have to work around building an architecture to fit it? So the first is, everybody knows when you go in, you tap your card, and you go through the gantry. But what happens? You tap your card, it has to go through, recognize the card, it goes back to the system, a debit is made, make sure that the card is valid, and then the gate opens. But it has to happen really fast because they have to move people. So we're talking maybe 200 milliseconds that you've got for that whole system to be able to update and open for you. So okay, that's an interesting case. So you're talking a 200 millisecond case. Another one may be CCTV. So if you've ever been to Singapore before, you've seen they've got cameras everywhere. Well, there's more cameras than there are people to look at them, so they have automation of the analytics. You've got the systems that are able to do facial recognition, and they're looking at zone control, and they're looking at a number of different features of how dense a crowd is and if there's people of interest. But this has to happen fairly quickly, but it's not milliseconds. Now we're talking there's a couple of seconds they've got to be able to make meaningful analysis out of this. Well, you see the lady, she's on her phone right now, and if you go in and you get one of the cards, well, you may have a top-up, right? So if you need to put more balance on, and you walk into the train station, it can detect and say, hey, before you try to go through before you tap in, you may not have enough balance to make it out to your destination. So your phone can then update you. And this should happen within maybe a shorter amount of time, maybe a few seconds or maybe a minute from when you arrive at the train station. Another real time may be having train arrival. So you've got the boards that are up, and if you've seen this at bus stations and train stops. So you're talking real-time update on the train, but that really just means within a minute, right? As the train passes through different stations, the sensors are picking that up. So all that sensor data has to flow back in and make those analytics. Flow detection. So you've got Wi-Fi hotspots, and we're all familiar with, more and more as you walk through convention centers and casinos and retail shops, there's these Wi-Fi hotspots. Now, Wi-Fi hotspots are getting a little bit better, but we're still looking at around maybe within 3 meters. You can triangulate down to 3 meters where individuals are. So recognizing who's there, looking at hotspots of activity. So maybe the people who are running the train stations are able to then do something to help with flow control during certain times of day. And the last would be climate control. So real time for climate control is not milliseconds, it's not seconds, it's minutes. So if they can detect that there's a large influx of people and the temperature is going up, they're able to respond to that and be able to automate the control of the building to increase the air conditioning or maybe increase the heating. So it's interesting, right? We look at this, totally different data types, totally different business cases, and the infrastructure needed to be able to run these systems looks different underneath for each one of them. So let's start to dig in and look at the three cases that the three structures that we typically see when we start to see these cases built out. So there's three categories that we'll typically look at for real time. The first is concurrency. So massive concurrency, think of this as there's a limited amount of resource and a lot of people are diving on that resource. So how to handle that in real time. So there's a case in Singapore where I'm living. One of the big telcos there, they are like most telcos, they have a very large postpaid mobile service. And a really important part of having a postpaid service is having renewals when it's the end of contract. Well, how is it that we're incentivized to renew our contract is normally through things like free phones, right? So they had this big launch around the iPhone 5. The iPhone 5, in their words, it just didn't go very well. They were pretty unhappy with it. So they came to us and they said, hey, let's work together. And when we launch the iPhone 6, we want to be able to provision these out and have no misallocations. We want to have all the bookings for pickups, and we want to have that go really smoothly. So we started with them, and I'll explain a little bit what this diagram looks like. It's pretty familiar if you work with analytics workflows, is typically customers will, or people will look at starting on the left, like what's my data, and then how do I put it into the system, how do I analyze it, and then how do I present it. But actually the customers who are building real-time systems and are building platforms, they start on the right side. They start with the smallest amount of things they're trying to fix, and then they work backwards. So this telco was looking at, we need to be able to provision all of the iPhone 6s, we need to provision the inventory of pickup slots, so time to go get these. We have to do it in a way that when people dive on these resources, when we open up the phones, we can provision all of those immediately. We have to do that in the concurrency of hundreds of thousands at the same time. So they had to be able to build up to this. So they started off their inventory. Inventory is two things for them. It's the phones and it's the time to collect. So that was their inventory. They loaded it over into Amazon S3. So they put that into the storage. They then moved that into DynamoDB. Now, DynamoDB, as a NoSQL store, is really good at handling a vast array of keys. But one of the things that you have whenever you have something that's key value matched is you can get hotspots within your database, right? You can hotspots for access. So they wanted to limit the amount of concurrent users who are diving directly onto DynamoDB, and they did that by fronting it with Amazon Elasticache. So Elasticache was the front end that could handle a lot of the concurrent access. And I'll step through a little bit around how they did that and how they managed the connection back onto DynamoDB. So they created within Elasticache, they said, okay, this is the amount of, say, units of phones that are still available within a certain configuration, and these are the time slots that are available. When a person comes in online and they check, it first goes to the cache and says, hey, is this ready right now? If it is, it starts to process the order. When the order is finished processing, then it updates DynamoDB underneath, but it's the first time that the NoSQL database is accessed. So what you have is you have S3, where all the inventory comes in. All of the inventory is then loaded into DynamoDB. It's fronted by Elasticache, and it's wrapped with load balancing for the web servers. Right? So that's the real-time application that's running. Now, what I've drawn in on the right side of this is the user front end that's being fronted out. Now, this pattern, if you've built front ends, is pretty common. They'll run a DNS, so they run Route 53, and that's to be able to handle all the traffic coming in and route it to the best place. They're running CloudFront for all of the static content. And I'll share in a little bit why it's so important to split up the static and the live or the dynamic content. So all static content, web page and graphics and all of those things were stored down in S3 and surfaced out through CloudFront. And then the web servers that had to run the actual applications are wrapped within a load balancer. So the order comes in, the person comes online, they order the iPhone, they book a slot, and when it successfully completes and it goes through this whole process, DynamoDB is updated, the cache is updated, and then the user is given back, hey, here's a confirmation for your pickup time. Now, the outcome of this was the telco that had such a bad experience with the iPhone 5 launch was able to then clear their entire inventory of iPhone 6s in 2 minutes. And they had no governor on how fast this was running. So actually the feedback that they gave to us was the people who aren't very good on their smartphones, who are trying to make the orders, right, the people who are a bit slow, they missed the window. Because all the people who were really fast, they got the phones within 2 minutes. So actually for the iPhone 7 launch, they had to build in some timing. They had to slow down that process of being able to book the phones. So they were happier with the way they were able to architect and be able to scale that up. So feedback from them was going forward with the 7s and 8s and whatever other phones they were going to launch, that they would take a similar approach to be able to build that high concurrency with the CDN and static fronted, and then on the back end be able to really use a caching layer to protect their DynamoDB resource on the back. So that's one case. So this is around concurrency. What's another very interesting case? Context. So we look at what is context for us. Context is going to be where you are. It's going to be who you are. And more of the real-time applications are around location-based. So as an asset or a person is moving into or out of a zone, being able to trigger an event. AdRoll, so AdRoll, a very big customer of ours. I believe they've, you may have been to their session here or the one last year, but AdRoll is one of the largest retargeting companies in the world. And if you're not working in the advertising space, you may not be familiar with what retargeting is, but you've experienced it before. You've gone to a website, maybe an ad has been surfaced to you, and then you leave that website, you go to a different one, and the same ad appears, or a very similar ad appears. And that's the business of retargeting. So some company has been able to get a profile to say this is something that you may be interested in, and what they find is that if you don't respond, or that most people, roughly 95% of people, don't respond to an ad at all. They don't click through. So the business of retargeting is being able to find a better way to approach you so that you're interested in clicking through. So the scale that AdRoll operates at, they've got about 20,000 customers. They're spread across countries across the world, but they have a very unique challenge. If you go to a website and the ad takes a long time to load, the experience is not very seamless. It's a bit distracting. So they have a SLA to the people who book on their system, their advertisers, of sub-100 millisecond latency, no matter what country you are in the world. So being able to surface that ad and get it out to the web browser, whether they're through parts of Europe, through the US, through Africa, through Asia. So a pretty interesting challenge they've got technically. So the way they started on the right-hand side, and they're looking at the number one priority is sub-100 millisecond service. The second is they had to build, no matter what site, have cross-site ID matching. They had to, of course, build a retargeting system, but they also needed to automate the process of people who are booking ads, who are being able to come online and bid for those. So having an auctioning system that could then adjust in real time. They went back to the data sources, said, okay, to solve these problems, they need to first pull in, of course, the actual usage off the website. So they're looking at the web logs and the cookies. Also pulling in the bidding data that's been put in place. And one of the things that to get down to sub-100 millisecond, they need to be able to monitor continuously and then find if they get up to 150 or 200, what went wrong. So how to really dig down into to debugging this. So they use Kinesis as the on-ramp for all of these data sources. So for all the events flow into Kinesis. But because the scale that they're operating at, Kinesis just in a single set of shards wasn't going to be sufficient to handle their case. So they use the Kinesis client libraries, the KCL, and they buffer this out to a number of different Kinesis streams. So they then take a single point of entry and they split this out into other workers. So then those streams feed into different EC2 clusters, and those clusters each have different workloads that they're performing. So the things that they're really after is, first, they need to be able to serve ads, but they want to have an independent system that can provide the bidding, the online bidding system. So they had EC2 pushing out through DynamoDB, and the pattern that you see here, this is a very common pattern that we see with our customers, is they use Kinesis for the on-ramp of an event, and they use DynamoDB for very low latency push out, so the off-ramp for an event. So these two tend to pair pretty well together. They're using HBase as a way to be able to scale up for their real-time bidding system, so that was their platform of choice. Now, on the bottom side of this, they needed to create, check their models and look at, hey, the ads that were surfaced, were they the right ads? Were there click-throughs? what was the performance of the ads as they were served. So they use CloudWatch to capture the events, and they're using Datadog to be able to do the analytics of that, and then really drill down into root cause if there's some sort of latency issue. All the analytics were then pushed into S3, and then they had another application server that was running the analytics for them. What they found coming off this was they initially were looking at having to suit that 100 millisecond SLA to their customers, and they were finding they were able to drop down a lot the operating cost and the upfront cost for them. So they're about 75% cut in operational, or in fixed, and 83% on operations. So here was the interesting thing that they found from a retargeting side was about 90% of customers or visitors to a website don't respond to an ad, but by retargeting and moving that across, there's a significant uptick. So they're looking at 80+% of people are more likely to respond as they see ads on subsequent pages. So for the retargeting business was really a big lift for them. The peaks that they were operating at is they were running about 2 million transactions per second at peak load. So again, from a real-time standpoint, when you're looking at this across the likes of Nigeria and looking across Czech Republic, was a pretty big technical challenge that they worked through. Now the third, so we've looked at concurrency, we've looked at context, and so the third is around continuous feeds. And a lot of customers are very interested in what they're going to do in the IoT space, what they're going to do with connected devices. There's a very unique challenge that you'll face when you start to get into this space, which is the signal-to-noise ratio problem and how to respond to events when you've got such a large amount of data, but only a small amount of it is the actual event you're trying to respond to. So a customer of ours that they presented earlier this week is a company called Hello. And Hello, they're in the business of creating software and hardware that, as they say, is to improve life quality. And the way they do it is they do it by measuring the quality of your sleep. So there's a lot of apps that are already out there that measure how long you slept. Like I'm wearing one of these watches that tells me you slept for this long, and then this is the quality. This is when you're deep and medium and light sleep. But it doesn't tell me why. And it definitely doesn't tell me what I could do differently to make that better. So Hello got into the business of trying to answer that question. And the way that they did it was they created a pair of devices called HelloSense. And HelloSense is a bedroom device that looks like this. So you've got this little white ball that sits in the room, and it checks things like air quality, and it checks if there's, if there's light, if there's sound, and it looks at the time, and then it correlates in to that little button that sits on the pillow. You see there's another little white device clipped to the pillow, and it looks to say, hey, is this your restlessness? And then can we find a relationship to what's going on in your room, and can you start to change your environment so you get better sleep? So it's a pretty interesting approach to being able to solve that problem. Now, the way that they went through it was, again, they started on the right side here of what they wanted to accomplish. The first was they wanted to build a way that you could have a sleep score and you could look at your trends of how you're sleeping. They also wanted to be able to find, are there patterns within, say, a given region? So within a particular street or a neighborhood, are there trends where people are sleeping better or worse? So not just looking at the micro environment, but also starting to look at more and more macro environments. Also looking at why, right? So answering this root cause analysis of why is your sleep not great and what can you do differently to improve that? So they had another interesting tweak that they made, which is sometimes you wake up, like your alarm goes off and you wake up and you feel terrible and you're really groggy. It's because you're waking up at the wrong time in your sleep cycle. So it starts to measure when you're at your deepest point and when you're at your lightest point. And if it means setting your alarm 15 minutes earlier, the system dynamically adapts and says, hey, let me wake you up so you feel the most refreshed when you start your day. So answering some interesting questions around sleep. They went back and they answered this through finding all that data that's coming off those two devices. So they're pulling the sensor data off of both the bedside device and also the pillow device. They pull that into a system, and this is where I'll say the connected device challenge is really a common pattern that we'll see with people who are getting in the IoT space. There tends to be a filtering system, an aggregation system that has to be built at the beginning of this flow, right? Just flowing in raw data, you get so much noise. All this data that doesn't necessarily mean anything, but if you have something like this filtering on the front, you're able to do, say, compression of repeated signals. So let's say that there is no meaningful signal over an hour. You can compress that down so that that data isn't flowing in for analytics. You can get a lot of compression off that data. So they're using, at the scale that they're operating at, and as they move this more and more devices out, it's very important for them to be able to filter as much data as possible before they start to load up their data warehouse and their analytic systems. So using ELB and using a set of aggregators at the beginning, they then take that, and at that point, they flow it into Kinesis. And they fork, at that point, they fork two streams out of Kinesis. One is they use a single Kinesis stream that feeds into Kinesis Firehose, and they move that over into Redshift. So once the data has been compressed and moved into Redshift, at that point, they can do things like analysis. So that's where they're doing their root cause analysis that will then push back the models. But at the same time, they serialize the data so that if they want to, say, give a customized alarm, or if they want to impact some sort of, they want to maybe send a message out through the device, they need to be able to do that in real time. So they move the serialized data up into S3. That data at this point, all of the data can flow back into Redshift, and from Redshift, that's where they're using, they have their own analytics tools, and so they build those, and that's available to the analyst. But to impact the real-time event, they are using two different systems on the back. They use DynamoDB. Again, think of Kinesis as the on-ramp, and DynamoDB as the off-ramp for an event. So when DynamoDB receives this trigger to say, I'm going to go out and I'm going to update the device, and I'm going to trigger that alarm to go off 15 minutes earlier, it's Dynamo that's able to surface that out. But let's say somebody comes in and says, show me my trends. Show me how I'm sleeping better or worse over the last week or last month. Then actually RDS, what they're finding is that Postgres is really the better option for them to be able to receive these queries. So when somebody opens their app, it goes back and it hits RDS for Postgres. Now, to be able to do load management, pretty expectable pattern. So you've got your mobile devices. The mobile devices connect into an application server or web server, and that's sitting within load balancing. And the load balancing manages the API calls back down to the underlying databases. So where they're able to come with this was they've now scaled up from being a very, very small startup that they're able to now move out, and they've got a small engineering team. I think last I heard, I think they've got 5 engineers who are building these products. So pretty awesome story for them, and they're now moving up to handling millions of events per day. And the applications they've got, they're now able to move this out. They're shipping the devices, and they're spending their time really building the applications rather than getting in underneath and having to manage the real-time systems. So what about for you? So how do you get started? I don't know how many of you have gone down the road of trying to build real-time systems, but it's really hard to go through traditional methods and build something that costs you less than $1,000, really something that's meaningful, that doesn't have a really high upfront cost. So let's look at a good way to get started on this. So again, let's start with this pattern of what do we want to accomplish first, and then let's work backwards to how to architect for it. So let's take the case of let's build a website, and we'll have a website that has thousands of concurrent users. It needs to be able to stream out applications, stream video, so something that has some sort of multimedia service that's going on. Users who are coming in are able to look back at their account so they can make some queries off the backend system. And also we want to look at customized content. So as you click in the system will respond to the user and be able to surface something that is personalized. The first thing to look at, really where you can save a lot from an optimization, is offload your web servers as much as possible. So using CDN and using the front end is going to be a way to take a lot of the unnecessary costs off of the web servers. So let's first look at what are the 6 things that we're trying to accomplish. We've got static, we're looking at video streaming, monitoring, looking at information for the accounts, having behavioral modeling, and customized content. We'll start with the first 3. The first 3, you can solve a lot of this with 4 of the services. So you have CloudWatch, and CloudWatch is going to be for looking at performance tuning, performance metrics. At the scale that I've put up for those within those boundaries, those parameters, you're really looking at within free tier, you can get a lot of metrics out of it. So this is a small cost. S3, object storage. Now the prices that I put up here are the prices before the price cuts that were just announced. So this has even dropped down a little bit. CDN is with Amazon CloudFront, and Route 53 for the DNS, being able to route that traffic as it comes in. This is the size that we should expect within this case, right? So thousands of concurrent users, we probably are looking at surfacing at about 1 terabyte of site content. Again, 1,000 concurrent users, That should come up to around 1 million visitors a month, something like this. So, mid-small size to start with. Pricing will be based out of US East, and we've got static content downloaded maybe about 5 terabytes. So it's a smallish application to start with. What we'll do is we'll start first by, again, offloading the web server. So we have Route 53. We'll use CloudFront to surface the content, and the static is going to come off of S3 on the back end. Now, because you don't pay anything for moving S3 content out through CloudFront within the same region, you're really looking at the biggest cost here is going to be around the CDN. So you've got about $425 that'll be the cost for that. DNS is essentially free. It's about $1 to run for the month. And then you've got a little bit, so $30 that is sitting on the back end for S3. Monitoring, build it in. The cost of it is insignificant in this configuration. So let's dig back deeper. So what have we offloaded? We moved the static content off to content delivery network, but what about on the back end? So we have the web servers, and we want to run our web servers for account applications. So we'll want to have load balancing, and we'll look at a web server. For the scale that we're operating, we're looking at C4s, so C4 larges, and let's do a couple of those. So we'll look at 4 of those split across 2 AZs. So we'll take 2 and 2 within US East, and we'll back those with maybe 100 gigabyte SSDs. So that should be about enough. The cost of that will come up to just under $20 for load balancing. And the C4 large has dropped down within US East. I think that dropped about 5%. Other regions has dropped by up to 15%. So 340 may actually be for you about 320 or less now with the price cuts. So this takes the total bill up to 817. So what we have at this point is we have web servers that are running, and we've got content that can be surfaced out. Now, the next part is decouple as much as possible. So application servers should not have any of the data that's stored within those SSDs. So let's use S3, which is essentially, it's about as cheap as you can have for a storage service, and it scales up. So unlimited really for any use cases that we're looking at. So let's see where we can decouple with Kinesis. We'll decouple with EMR, with Redshift, and with QuickSight. So Kinesis, we've seen this earlier, and maybe a service that you're already familiar with, but it's that on-ramp for events, so capturing real-time streaming events. Amazon EMR, or Elastic MapReduce, is the fully managed Hadoop offering. Now, what makes this Hadoop offering look quite different, and earlier in the keynotes, we heard about the features, but there's an underlying capability of this that's really different from other Hadoop, which is you're able to decouple the storage, the HDFS and the storage away from the compute, which means you're able to start and stop your clusters. So you can have your HDFS that's persisted in S3, you run using EMR-FS, you run your compute, and then you throw it away. And then when you're ready to run it again, you start your compute again, which means you're not having to pay for this long-standing persistent Hadoop cluster. Now, again, from a costing standpoint, this can make a really big difference for people who are running large jobs but infrequently. Amazon Redshift, data warehousing, and QuickSight for the BI component. Now, what I've done is just so this doesn't sort of overwhelm you guys, I've grayed out the areas that we've already seen. We'll just look at the new parts, which are the colored services. So events come in through Kinesis, so capturing things like clickstream and capturing transactions. All of that will flow into S3. So the user actions, whether they're batch or whether they're streaming, will land into S3. Once they get into S3, the ones that need context, right? So the ones that are semi-structured, like clickstream data, will be processed within Hadoop, be processed within EMR, and then pushed into Redshift in a contextualized form. So data tables will be created and loaded into the data warehouse. Now, transactional data already looks pretty nice and clean and structured, so we'll just load the transactional data from S3 directly into Redshift and merge those. So now you're looking at, Kinesis is about $50. You can see the other pricing. S3 is pretty low at 8, and then EMR, if you're running this with EMR-FS and you're able to shut this down as you need, you can keep that to about $50 a month, and Redshift at 20. So again, from a job standpoint, you're looking at EMR running about 20 hours and running this 16 times a month. So enough to be able to process on a weekly basis several times that user data. So, and QuickSight, let's say we'll put 4 business analysts who can come in and look at this and run some analytics against it. And so that'll take that up about another $36. So the total bill now is you've got something that's running, serving static content, serving video content, people can access their applications, doing analytics against clickstream, and you're still under $1,000 at this point. So that's a pretty compact system that's running, and at a reasonable scale if you're doing POCs and you're starting out. Now, what if we want to get into customized content and personalized content? So we saw before that NoSQL was being used for very large scale, but not in the way where we're looking at it just from storing content, but getting low latency access. So using DynamoDB for low latency, using Elasticache to front that so we don't, if we have hotspots, we don't overload those. Lambda, looking at that for serverless compute, and SQS in some configurations if you need to be able to hook that onto other parts of your queuing system. Now, I've cheated a little bit, and I haven't put in all the prices because how it gets implemented, all the other parts we can really measure and say this is the volumes of data, the volumes of content, but how you implement for serverless compute, how much you put there, and for caching, can make this part vary quite a bit. But still at the scales that we're operating at, we should keep it very close to 1,000 or maybe 1,050 at this point. And I'll claim that because we had some price cuts, I might still be able to get this under $1,000. But what this shows you is that from a customized content, as that event happens and it lands in Kinesis, it then is processed within Lambda. So the serverless function runs, recognizes the event. It then goes into it pushes into DynamoDB the action that should be given back out to the user. And then through Elasticache, you're able to serve that out very quickly. So as that person who's visiting the website is looking at content, they can receive very customized content. The moment that it's updated, the cache is updated and serve it out to them. So again, a very lean architecture, but one that will scale up as you move from 1,000 concurrent to 100,000 concurrent. So what we see is that actually by starting with looking at the business requirements and looking at the timing, we can really keep down the scope so we don't overcommit as we're building these architectures. We don't over-provision. We're able to keep down to a very lean architecture to begin with. And can start with, say, this sort of scale. I think a lot of people who will start and they say, we have this many users, we have this much content to push, are going to think that it's going to be a very painful start, or it may cost them quite a bit more to get that off the ground. So again, starting with the business requirements, working backwards, building very lean architectures to suit that. And what we're seeing is that more and more people who are starting on real-time aren't starting with these very large infrastructure builds. They're proving the business case first, and then if it turns out to be useful, then they can take that and scale it up. So with $1,000, you may be able to get more out of your system than you expected to before. So with that, I'll leave you, what are the 4 things that you can do and that we see as really the best practices that our customers do? Is the first is start with the smallest case that you're trying to build for, and then work backwards to have a very lean set of components that you're using. So start really talking about from a window of opportunity, how much, are we talking milliseconds? Are we talking seconds or minutes? And don't try to over-provision at the beginning because you can always architect to have more robustness or faster systems later. The second is everywhere you can decouple. Decouple your web servers, decouple your storage out of Hadoop, decouple your storage out of your data warehousing, decouple your storage out of your serverless compute. S3 is going to scale up and it's going to be a lot more cost effective as you start to build at scale, and then you can choose which services to then flow that data into. The third is, and I know all of you guys have been in the business of cloud for a while, but using services more than servers. So, if it's already been built, not having to build this on your own, not having to upgrade and maintain on your own. And the last is staying current. So as you've got local resources and you've got access to training courses, essays, certifications, we're really doing the best that we can to try to make this available to you and give you the best people and access to that information. So with that, I'd like to thank you all very much. I really appreciate you coming in and sharing this last bit of the day with me, and I hope you have a great day. I'll be here for questions afterwards. So thank you very much.